Dear friends, now we are beginning our webinar on importance of fixture design in new product development. Welcome to everyone. As I said, we are into the new mind of the world. If you start agriculture today to the conceptual age, any parts can be manufactured. If you could look here, these parts, if you want to manufacture, what's the only way? As I said, many people, I'm just a little bit zooming it forward and I'm just doing that. Imagine if I'm trying to move this parts, if you want to manufacture, earlier people, what they do, if you take any automobile companies or any company, they all run, they have hundreds of machines they use to manufacture the parts, which is continuous. But today the scenario is all changing. Everybody, they need to develop a lot of new product developments in the conceptual age. There is a huge opportunities. You might be knowing it under the COVID-19 challenges. India, it's going to be, many people say it's going to be a threat, but in the other scenario, if you could call it, it's going to be huge opportunity. Many people wants to come out of China and going to invest in India as well as Indonesia, maybe other parts of Southeast Asia. What is our important role is we need to have a setup how these parts can be manufactured. If you want to manufacture all these parts, you might be knowing it, you may need a CNC machine. Just imagine whatever I showed the parts, if you want to manufacture this is how typically look like. When overall into the industry or overall into the educational students or professors, they'll be all knowing it. All this type of parts to be manufactured. I'll just give a bird's eye view. This is how it can be manufactured. All this is very, very important is the various process to be followed to see the outcome of this actually. If you could do it, this is doing a milling. Now I'm doing horizontal machining operation. Any part, if you look at it, the parts to be manufactured very quickly. Today, generally, if you take any persons to manufacture all these parts, they need development time, lead time. Maybe people say, I need a 3 weeks time or maybe 6 weeks time. I need to manufacture, I need to order cutting tools. I need to do the fixture design. I need to have, get ready so many things. It's a challenge. But today, what the world is looking forward is to develop the product just in time. If the customer gives the order, even you can charge more, but you have to do it on the next day or next week to be followed. And the future is going to be not a huge number of volume. It's going to be a small batch quantity, but rate wise, it's very good actually. What the people are looking at is, if you look at it, anybody who is overall into the export manufacturing, they will say, my volumes are less, but my profitability is very good. Even the customer is allowing, you can add, there is a column called profit in the business. So what is very important is all these parts to be manufactured like this, what are the steps we need to follow? If you could look, either start with automotive, or if you take it medical or bearing, or if you take marine, every industry, they started using CNC machines, and which the CNC machine, you need to follow certain process. So this is the entire, the new product development cycles. First is you have to do the drawing study. As you know, the drawing study is a basic engineer's language, and which even I'm an engineer, but I learned in my first career in Rane Madras because it's challenging. And people today, whatever you call it, you have AutoCAD or you have a 3D. What is very important is you should know how to read the drawing. That is very, very basics. And GD&T, or if you could take it, widths and limits and tolerance, all this is very important. The next important thing is, this is little lagging with many of our people because we never think beyond. What we call it process planning. So what is a process planning is nothing but, of course, we are going to see one example. Process planning is nothing but you have to compare with input and output of the component. Then you should decide what are the machines I'm going to use, what are the method I'm going to use, and all this which you are going to plan. And whether I'm going to do it in single setup, multiple setups, all this plays a major role, whether it can be done in turning center, whether it can be done in turn mill, what is the machine, or maybe a HMC, horizontal machining center or vertical machining center, that is very, very important. Then is machine selection. You cannot do the process planning, which is the machines which is not available in your factory. What is very important is you should do the machine selection in the process planning based on the machine availability or CNC machines or whatever availability. Based on that only your process planning should rely on that. Next important thing is cutting tool selection, because this is the other very important, depending upon your material, whether I can use solid carbide, whether I can go with insert type, or whether I can use what is the best way which I can do. So what we can always say is, in the modern world, everybody is having a CNC machines. It's very important. What is very important is in what way I can be differentiate, or what way I can do the best in the world. As I said, you no need to compare with other companies. What is very, very important is you have to compare with your own methodology. The key engine of the new product development is fixture design. Fixture design is always gray area, which I can also share one of my experience. When I started my career in Rane Madras, I can still remember the person who taught me the fixture design. His name is Mr. Ramanuja Sheshadri. He was from Sundaram Clayton, TVS Motor. He taught me the entire fixture design, how it can be done, assembly fixture, machining fixture, a lot of concepts, which always people can say it's not available in the book. And I'm going to share some tips in this coming presentations, which we can give a bird's eye view. Fixture design plays the major role in the industry, and which we always, what other thing we can do is, always in the fixture design we never questions the basics. What happens is somebody did the design like this. The same way the next guy also, just what do you do? Many of the automotive or wall companies, they do the similar parts. Somebody did a fixture design maybe 10 years before or 5 years before. They do only they change the shape and size. No, it won't help. What we always say is, if you want to do the productivity improvement, if you want to do the best products, always you should question the fixtures. Next is CNC programming, which you can use CAM software like HCAM or any leading CAM, or you can use manual programming. Then finally you are going to do the live machining. And today the new concept which is coming is in-process inspection. You can use probes or tool setters, which you can measure the parts in the CNC machine itself, whether no need to take it to CMM. Of course, any critical components which you can take it to CMM, but in general you can do it inspection in the CNC machine itself, and from the machine you can straight away take the part. Of course, you can do the documentation as well. So this is the overall the new product development cycle. Now we are going to drill down more on fixture design because time is limited. Let me just see the fixture design opportunities. Over 3 lakh industries. As a basic conception, maybe I have many students who are all coming out of engineering. We used to ask them, what is your career plan, or which area you want to go? People generally say, I want to go in design. Then I used to ask further, what design? No idea. People thinks even in the design you have a 2 category. One is product design. The second one is PED, production engineering design or manufacturing engineering design. What the people thinks generally is learning the 3D model is the design. No, I would like to put forward very clearly, 3D modeling is a just tool. You should know the basic, whether it is going to be a product design, you should know what is the casting elements you should give, whether it can be produced, in what way it can be manufactured, whether it is a GDC or whether it's a pressure die casting, whether in case of aluminum, injection molding, compression molding. The same way, if you are want to do it on manufacturing engineering design, people generally they'll be into the new product development, and they'll be doing all the cycles, whatever I said. Initially they do the new product development, then they do the continuous productivity improvement. There is a 3 lakhs industries looking forward for the engineers who can do the new product development. But if you could take, this is a demand, available resource is this much, and whoever is available resource also, they are not upgrading the skill set. And let me just put forward what is the very importance of the fixture design. Already I said, any new product development, I will just show some examples. So this is typically the part which can all these parts picture. If you could take this example, this is basically a component, and this is a fixture. And this is of course hydraulic fixture. Fixturing, there is a many types are available: manual clamping fixture, hydraulic clamping fixture. And if you could look, this is without component. if you could look, this clamping and everything is been done by hydraulic, and manual clamping is also there. These are all the pictures which every industry is looking forward for the engineer can do. This you cannot subcontract to anyone. For the engineer who knows this, or who want to, somebody is into the purchase, somebody is into the development of methods. If they learn the picture design, there is a huge opportunity for them. They can look at the entire things in a different way. So this is an example with loaded component condition. It's a backside, and this is with a component. I hope so you're all seeing it. Component, and this is a fixture parts. What we are industry is looking forward to design engineers like this. This is horizontal machining center, HMC fixture, tombstone fixture, I can call it. This is with a component. I hope so you can compare this. This is a manual clamping. You'll be loading the part like this. So this is once again a manual clamping fixtures. This is again hydraulic clamping fixtures. This is aluminum. So this is a type of fixtures which industry is looking forward from the people. But what is the challenge which we have it? As I said, the fixture design is playing the major role into the new product development cycle. And can we learn the fixture design from the book, or can we learn from the syllabus? Of course, some of the engineering syllabus is available, but in general it was an elective, and it's once again the theory was explained, not in detail, practical. As I said, always there is a difference between knowledge and skill. Generally, like including me, I learned the fixture design in the industry. And maybe let me share just one small bird's eye view of fixture design, what we can do, step-by-step procedure in the limited 30 minutes time. This is the picture which we are going to go total, maybe a bird's eye view of the fixture, how it can be designed. This is a milling fixture design, vertical machining center. The first step is process planning. If you could look, these are all the steps which we have explained. Initially, you have to study the drawing. You have to compare with the machined drawing and with the casting drawing. And you should compare what are all the operations to be performed. If you could look here, this I'm going to do. This dia 10.5, I'm just circling it. This 4 holes I'm going to do. And same way, this 4 I'm going to do. And same way, I need to see how much is the depth. All this we are going to do, whether it's a through hole. What is very important is, and similarly here, some turning operation to be performed. Here we have to do, and similarly this side hole to be done. So the first step is, if you could look here, there is a detail was given. First is drawing study, and some organization they give a 3D model, but generally in the inquiry stage they give only the 2D drawing, and supported by 3D model they can give. You should compare the both. Let me just go in detail in a 3D model. So this is basically a 3D model. How look like raw material? Typically, it has to be compared. Just I'm moving it. Then this is a finished component. Customer used to give a drawing along with the 3D model. All these 4 holes. As you said, the process planning is very, very important, which we are going to do. The 4 holes, which we need to do the drilling. Then finally, we are going to do the top hole drilling also, and there is one more hole also which we have to do that. So this is typically the one, and then is we have to see the machine travel, whether the machine can do that. This is a small piece, it's okay, but if you want to keep a 3 component or 4 component fixture, you have to see the machine travel also. And the first step is selection of machine based on your component sizes and number of components to be accommodated in the fixture. But in this case, what we did is we did only one component. Therefore, this is a very small fixture. It can be accommodated with the machine. If you could look at it, this is a machine which we did it in HCAM. Generally, CAM can be also used for this type of benefit. Let me just move forward. You have to move what is the machine stroke length, all this which we can compare. The next is type of fixtures needed. What is very important is, if you look at it, these 2 operations where it's been marked here and other side, it can be done in turning. In this case, there is no need for fixture. You can hold it in a collet or check, whether it's a 4-jaw check or 3-jaw check. And the next one is, we need to perform all these 4 holes and this in a separate fixture. Let me imagine why you need a fixture. Imagination without machining a fixture. Imagine the world. If no one knows the fixture design, then what will happen? Imagine someone should hold this component in the hand like this. Absolutely little impossible. If you could look at it, then the operation will get performed. We did an imaginary simulation in HCAM software, which you can use it. If you could look this, imagine if the component is trying to drill, automatically, you know very well the component will try to tilt it. Absolutely, this operation will lead to accidents. And that's why we need a fixture. I hope so you all, if you imagine the world without fixture, it's very, very difficult. For that's the reason we need to go forward for the fixture. As we said, the fixture design principle, it's very, very important. I can put it CLRO concept. If you answer CLRO, then the fixture design concept is been completed. Let me just take one example. I mean to say, what is the meaning of L? Any guess? L is location. If you want to locate the component, you have to locate. If you could look at it, this is not a round one. It is into the different shapes, which you can easily loading and unloading can be done. So this is location. The next is orientation. O means orientation. The orientation, the difference is you have to restrict. When you're trying to load the component, it may try to tilt it. You can load it in any way. For orientation plays a major role. That's where we introduced V block here. If you could look at it, this is for location and this one is for V block for orientation. I have not explained what is the meaning of C and R. You can all think over it. And maybe you can answer me at the end, or maybe if you want to know more about this, then you can join in our courses. Apart from this, the people call it various things to be considered. They call it 6 degrees of freedom, operation, so much of things which the start with basically is CLRO. If you answer CLRO, the fixture design 50% it's over. Now we are going to see practically how these operations are going to perform in the machine. So this is how after the fixture is being done, all the operations are being done like this. Now it will not tilt, it will not fall, secured, it's located properly, it's oriented properly, and operations has been success. But this is actually, once you did a fixture design, how it's look like. So what we did is, we are not making things very complex. We are starting from the basics, explaining the concepts, then we are upgrading to the future. So this is how it look like. All the 4 holes are being done. Then same way which you can do this small 2 holes. That's where the entire my live in action is being done. Is it over? Imagine, is it over? If I did a 3D model, I'm just going to show like this. If you could look at it. Is it my, if I did this model, is my fixture design is over? No. What is very important is, the big challenge with industry is, sorry, let me just put forward, manufacturing detail drawing. The basic might of the people thinks that manufacturing drawing is easy. No. Even in my own experience, I can do the model in 2 days, but for detailed drawing, we take 4 days. But you can still do it little lesser date. What is very important is, people many times they used to miss. Similarly, you can add here the datums. The assembly drawing is very, very important. Bill of material is very, very important. The raw material size which you have to put, it will be little higher than this. Let me go in little detail. So this is very, very important, because in this detailed drawing only you're going to do the material selection. If you take V block, if my component material is aluminum, then I need to take EM24. If my component dimensions are little bit zoom it. If you could look at it here, let me just zoom it. I'm just moving forward. I'm trying to find, is there any mistake? If you could look at it, both to be has to be grinded, because when you are trying to assemble the components, the grinding symbol given, almost there is no mistake here. But if you look at it here, the V block, this 35.9 could have been changed to 37, because it's not important. I'm just changing it to 36. Rest of the time there is no error. What is very important is, you should know if my component material is stainless steel, the V block materials are different. And similarly, if my the component is little critical dimension, then the V block I need to introduce wear pads. All this are very, very key role in the fixture design. The detailed drawing plays the major role, because the part to be manufactured. Therefore, the student or who are all undergoing the fixture design, the basic fundamental principle is they should know dimensioning, they should know about GD&T, tolerancing, limits, fits. If you could look here, I put 25H7, and same way the mating part I could have done it G6. All this you should know. How can you, now coming back, I just showed the glimpses. How can you learn the skill? With my life experience. A year before I want to, or maybe 2 years before I want to do Ironman, which involves swimming, cycling, running, which even I don't know the swimming, but I took 1 year practice for this, and finally I completed the success of Ironman. The same way, can you learn the fixture design from the book, or can be from the internet? That's the reason which